Hello, fellow data science enthusiasts. Welcome to the another rewritten episode of the Data Query Podcast. We've been gone for some time and we're very delighted from the feedback we got requesting for the show to be back, meaning you're finding this show very valuable in scaling your career to the next level. And like always, I'm joined by my co-host, William, and as guest today on the show, we'll be having Prince Canuma. Prince is an MLOps and a DevRel with Neptune AI. We'll be talking about his transition from a web dev to an LMOps. What is the difference between an LMOps and a DevOps? Some of the difficulties he entails productionizing ML applications, and also at the same time, Prince has one of the articles featured in the Stanford classes of productionizing ML applications covered by Andrew NG. So we'll be talking about also what it entails writing beautiful deep technical articles that it becomes clairvoyant, because sometimes understanding technical topics becomes very difficult and blurry. And like Richard Feynman once said, or once put it, explaining technical things with simplicity that even a 10-year-old can understand or relate with. So if you do find this show very valuable, please leave us a 5-star review, spread the word, and hang on tight as we query this young bright mind. Hello, William. It's another beautiful day to be having a deep conversation about a topic in the field of data science. And each time we sit around for these conversations, I always get so excited because I always come out of this talk more knowledgeable about a subject or field because of the depth of which we cover some of these topics. What about you, William?
I'm more excited than you are.
So what are we going to be talking about?
MLOps.
And why are you excited about it?
Because they are talking about bringing our models into production and also into the user's hands.
Yeah, because most of the time we work with most of our data science tools in Jupyter notebooks and doesn't have real value to users' hands. So
yeah, we don't get for modeling, you also have to bring it like to live and also to users' hands. And I think the perfect person to even talk about this is going to be
Prince Caduma with us on the show today. And we're very excited to have this young bright man with us on the show today, because he has a very deep experience in the field of LMOps and has a very good article about what LMOps is, and which is really referred in one of the classes at Stanford. And coming from a humble beginning to where he is now in LMOps, we're very excited to explore this field with him for the next couple of minutes we're going to be having. Welcome on board, Prince.
Hi, thank you for having me. This is a pleasure. I'm excited to be here. I heard previous podcasts, and I cannot wait to get in.
Thank you, Prince, and we're very excited.
It's very nice having you on the show. It's such a pleasure to have you on the show. And yeah, so today we are just going to be talking about MLOps, and we are going to dive deeper into it. You've written so many articles about it. Obviously, you've got vast knowledge about this topic that we are going to be discussing. So yeah. So I mean, as we mentioned, today is all about MLOps. And before we even start, we would also like to know how you even got into computer science, what inspired you to become an MLOps engineer, and how you even went about the whole situation to get to where you are now.
Oh wow, that is a very interesting question. I don't get asked that very often. So I think it was from a young age, ever since I was a baby. I think I have a picture at 2 on a computer, and I wouldn't leave the computer at home alone. So that's pretty much kind of the starting point. And later on, I wanted to become a scientist, which prompted me to ask the bigger question: between software and hardware, what travels faster around the world? And for me, I saw that software can spread faster, so the impact I could have would be much larger, and it would spread across the world without any issues with the advent of the internet. So that was kind of the first time I realized that I should be in computer science and engineering. Later on, I was excited about studying abroad. It is something that I really wanted to do from a very, very young age. That's why I started learning English early. And my mom just reminded me last year. She said, when you were a kid, you used to say, I'm going to learn English because this will allow me to travel the world. And boy, was I right. I wanted to study abroad. I looked for the country that has the best people in the industry, and that was India. The CEOs of all the big tech companies that we admire and use their products daily. Majority of them are like Indian, so went to India. And funny thing, on the same year, before I traveled, I watched Google I/O extended a broadcast in Mozambique with a group with a part of a community called MozDevs, which is like Mozambican developers. Shout out to them. A lot of the things that I learned and the passion started truly when I met that group of people there. And during that event, the TensorFlow was announced, and I was like, AI is gonna change the world. And I just switched my entire career. I was a full stack web developer then, and I just said, in the next 5 years, I will break into ML. And from 2017, I just started learning as much as I could. 2018, a year later, I started writing after a productive heartbreak. So I started writing articles as a means to get busy, and I realized that there is someone out there that doesn't know what I know today, and probably the Prince of 3 months ago didn't know what I know today. So I'm gonna push as much value as I can to the community, and that's kind of part of the writing side started. And at the same time, just the pursuit of knowledge. I'm a very curious person by nature. So that's how I got started.
Wow. So it looks like it all started from a very young age, and I mean your curiosity and everything to kept driving you to this point as well. And it's inspiring how you had to learn a whole language. And trust me, if you tell me now that English is not your first language, I'm going to be like, nah, that's a lie. Because anyway, that was very inspiring though. Okay. So yeah,
Thank
so
you.
even before we even continue with this podcast and everything, I also want to know, I mean, what's MLOps? Because I'm wondering, you've mentioned it, I think, quite a number of times now, but what was it? What's MLOps? And why is it important to the world of machine learning?
That is quite interesting. I could give you the direct answer, but I want to give a little bit of backstory then. I am a data scientist, 2017 to 2019, 20. I'm building a lot of projects as a consultant. I make a huge mistake by losing the JSON file that had all of the metrics for my project. So the customer comes and says, hey, your model does not work. And I go look, I ask him which model. It's like the latest model you deployed. And I don't know which model that is because I've trained like 3 models. So as a means to go about it, I do an ensemble of all the 3 models, try to do an average of the prediction. So whichever model that worked the best, that's how I chose it. And still the customer came and said, well, it only worked for a couple, but it doesn't work in general. That's when I discovered Neptune. After I lost that contract, the customer was like, I don't want to do it anymore. I discovered that, hey, there's a tool called Neptune. There's a tool called weights and biases, and this whole new set of tools outside of TensorFlow and PyTorch were flooding the market. And I was like, okay, what is this? Then I start to understand that, there's something called MLOps, because the problem with most data scientists, they are focused on just building the model on a notebook and that's it. But you don't get any value by just building models that get dusty in a notebook. Therefore, I discovered MLOps, which is a set of practices for collaboration and communication between data scientists, researchers, and operation professionals. These are your machine learning engineers and your platform engineers.
Yeah.
I hope that answers the question.
Yeah, it kind of answers the question, but I mean, like, that's from a high level perspective. But to the guy on the street, I don't know, like, what you think, like, can you break that, like, to what MLOps guys do, like, yeah, for the layman?
Okay, so basically, there's no set rules set in stone. It's just standard best practices of how you go about things. The same way when you're developing normal software in DevOps, you have code versioning. Those are just practices that help you recreate the results you had previously. So MLOps is just a set of practices, meaning you, instead of using a notebook, some teams might prefer to use Python scripts. But some teams prefer notebooks, but how do you do the handoff from a notebook to the machine learning engineer that's gonna take the notebook, the model weight files, and kind of put that into production? Some use Docker as a ways to reproduce an entire experiment, because you can save the environment variables, the dependencies, meaning, so there are multiple ways teams work around this. You just have to choose the best way for your team, for your scale. Because, for example, some might have CI/CD pipelines, but if you're very early, this is your first time doing it, you might want to do things a little bit more manually. So it doesn't tell you exactly what you should do. It just gives you a set of practices that you can pick and choose for your current environment.
Okay, great. You did mention about, weights and biases, and more specific Neptune AI, the company which you work for. So,
Yeah.
For those who do not have who do not know what Neptune AI is, what can you give a brief, explanation of what Neptune AI does, and also how also Neptune AI helps business with their LM ops needs?
Absolutely. So Neptune AI is a metadata store for research and production teams that run a lot of experiments. What is a metadata store? So we know that metadata is data about data, meaning that we are storing all the data that all the metadata that you produce throughout your machine learning development process. An example of that is dataset versioning. So you can version your data sets in such a way that it will be linked to a specific experiment so that you can know how many, for example, images of dogs you had when you trained this model. So that if you go improve your data set, you can actually compare and see whether your results change based on the data set version that you had. So if you have an updated data set and the model has better results, so now you can know that whatever changes you made actually have an impact. That is one component, data versioning. Then we have experiment tracking, which is something that we started with and we are well known for. So it's the ability in machine learning, by nature is iterative, is experimental. You have to try different combinations. So we help you track all of those different experiments that you're trying when you're using ResNet, and you say, well, perhaps ResNet is not the best thing. Let me try some vision transformers. So you can track all of those different attempts you had and compare them. So this is very useful if you want to find out what is the best model for your use case. Because even if it has the best accuracy, doesn't mean it's always the best model, because it could have the best accuracy, but it can also be slow. So you can also compare it on various benchmarks or metrics as you wish.
Okay.
And
Great.
finally, we have the component of model registry, which is where you can version your model artifacts, meaning your model weights and some of the metadata around your final model. And you can manage stages, meaning you can take your model from a staging environment into production. So you can have two different versions. One is in staging, is the latest model you just trained. You have one in production. You can compare both, and if the new model is better than the one in production, you can easily switch it up.
Well, that's really interesting. What you guys are doing at Neptune AI. And there's also this, concept of bringing machine learning into production, which is very difficult, right? And you also mentioned that in your famous article, what LMOps is all about. So we want to know what are some of the challenges business face when it comes to implementing LMOps, and how do you help them to overcome those challenges?
Okay. We as Neptune, or me as Prince?
No, yes, LM Ops guy,
Okay.
and maybe one you can also talk about Neptune AI, but I feel more of the LM Ops,
Okay, so there are various challenges right now. This technology is still very early for a lot of companies. We see the big companies, they have super hyperscale. They have the budget. They're making the money with those models. But most teams are very early in their adoption. So there is a problem of choosing the right tooling. There is a problem in terms of resources. How do you allocate resources in a way that will make sense? So it really depends on what you're trying to do. What is your use case currently? Do you have a team to do this? Probably you have a team, but it's not such a big team. So then your decisions will be different compared to a bigger team. I hope that kind of answers the question, or you want me to go a little bit deeper?
No, I think it answers the question. And you see, you spoke about teams and having what's important is like having a team and knowing who's on board. So then
Yes.
the follow-up question now becomes, so how do you collaborate with, let's say, data scientists, engineers, and other stakeholders to ensure that like models are being deployed? How do you do the collaboration? Now that you've identified like the problem, how then do you do the collaboration? Obviously, everyone has like different background. So how do you blend everything?
So I think this kind of goes back to the fundamentals. In software, we have software management processes. We have your scrums, your Kanbans, and etc. In ML, you can create a hybrid process and find out what works for your team first. That's like the main thing. Like, find out how you can collaborate with your team more efficiently. Is it Scrum? Is it Kanban? What works for your team? That is like phase one. Then after that, you have to understand the project and define the scope. Do you guys already have a model in production? Or do you have, or it's still like your first model in production? So those are different questions you need to kind of have in mind. If it's your first model in production, you probably don't need a fancy CI/CD pipeline. You might just deploy a simple API, Flask, Fast API, whichever way you wish, and start iterating and gathering feedback. You don't have to do this end-to-end automated pipeline on your first deployment. So figure out where you are and then find out what are the requirements to put an MVP, a minimal viable product online, or minimal viable model in this case. So it will be an MVM.
Exactly.
So, and the simplest way, I've been telling this many teams for years, is the simplest way: start with a simple API. Figure out if you can have any impacts. This is what I call level 0. So actually, I came up with a concept of like different levels. Like, you have level 0, 1, because there was just no description around this. So I thought, well, this would be the simplest way of doing this. I read a course, good quality course back then was kind of showing this. So you're doing a manual labor, meaning you're writing your scripts, you are deploying them manually, setting up the machines. You don't have a fixed schedule of iterations. You don't have any continuous integration or continuous deployment pipeline. You don't have like proper best-in-class performance, because you still don't even understand the metrics you should be tracking. So you're pretty much tracking everything. And as you go, you're going to realize that perhaps the most important metric for me to track for my business use case is number of orders fulfilled, for example. Or you might want to track that and against number of people that are not satisfied, so you can iterate much faster. Then after that, you can start going to level 1. This is where you introduce your continuous training, where you can start having a pipeline that's somewhat automated. You gather feedback, you can start training your model again and push it to production. And as you continue to go up, you can go as fancy as you want until you go fully automated. The process is just, you only need a human to oversee it and kind of fix certain things, but it's pretty much automated for you.
Well, I mean, so talking about strategy, you spoke about level 0 strategies, and you spoken about modeling a lot. And So in your opinion, what do you think I mean, you kind of mentioned some, but what would you say the best practices are when it comes to monitoring and testing of ML models, like debugging of ML models in production? What would you say what are the best practices for debugging and also monitoring of machine learning models in terms
First
of
thing is, yeah, first thing, track everything. If you don't know what you should be tracking in the beginning, track everything as much as you can. Then you will start to see and measure how that works for you. Track every single thing. Track the outputs, the inputs, everything. You need data to kind of help you make data-driven decisions in terms of how you're gonna iterate with your model. The second question, could you repeat it, please?
Yes, it's about debugging.
Yeah, debugging your
Okay.
ML model. Yeah.
So debugging, there are a lot of great tools out there. Not sponsored or anything like that, but like there is a tool that I've been participating in their events recently. This is like Arise. There's also another tool called Evidently, and most professionals nowadays work with Prometheus and Grafana. So they can, once, since you're already monitoring, you can start to see whether your model is having, for example, like data drift. And from there, you can, since you're tracking the inputs outputs, you can go see, debug that situation. Meaning, if you have a classification model, let's say image classification, and you see that there's a shift, you can go look at the images, and then you realize, oh, the training images had lighting that is different from the production environment. The camera in production is probably not the best, while the pictures we took were with a professional camera. So you might have things like data drift. Then you start to address it slowly. There is no one silver bullet that I can tell you, do exactly like this and you'll always find a solution, because for different use cases you do things differently. But the general idea that I would share that has worked for me, worked for a lot of other professionals that I know and teams that I've helped, is track everything. Especially if you have a tool like Neptune, like Prometheus, and so on and so forth, you can log those into a place and start to visualize what is it that's wrong with your data, or how is it that your model is performing on a specific slice of your data set, or doesn't have to be your data set, it could even be like production data. And you'll start to identify perhaps the images of dogs, of a specific breed of dogs, is not the best that you could do. You need to improve that, but you'll only realize this if you start working on at a slice level of your data, meaning you're not taking the entire data set, but you're taking specific subgroups of your data set and start measuring the performance that way. I think this is also a technique, like try to segment your data set even in production, and try to monitor at that level. You can have global metrics, but try to have more kind of a specific broken down metrics. That's gonna help you, because your model could be performing really well at the global level, meaning you have 98% accuracy. But then when you do at the slice level, you realize that you are probably underserving a large segment of your data set.
Okay, I think this is also a good segue into the next question, where you talk about data in sense of, let me say, segmenting your data. But in this aspect, it's going to be versioning. So the next question obviously is like, how do you approach, let me say, data? Approach versioning and also reproducibility in the context of ML models. Sorry, that word was like coming out of my word.
That is fantastic.
Me. Yeah.
That's fantastic, because actually just last week I finished working on a how to guide on how to reproduce experiments with Neptune. So that probably will be released sometime down the line, but this is something that customers ask a lot. And just people in general in the industry want this. Of course, certain use case, I've talked to big teams that don't care about this. They probably do this once a year. But research teams usually want to do this a lot. So in terms of like reproducibility, you have to look at it this way. You need to version your data set for sure. if you want to be able to recreate your experiment, you need a snapshot of your data set. So there are tools that do this. So there is DVC, there's Neptune, and S3 bucket by default kind of does this, but
Okay.
you would need to work with, I think it will be easier to work with a high-level tool that will just retrieve the specific version for you. So you version your data set. What is the versioning of your data set? You calculate the hash of all of the files within your machine or the experiment, the machine you're running your experiment. It could be remote or local. So it will tell you whenever you train this experiment, you had 10 images of dogs, 10 images of cats, right? That's one part.
Yep.
Then you are on the experiment level. You are running your experiment with that data set. What are you tracking there? You need to track, of course, you need to do code versioning. You need to know what script produced that experiment. Second thing, the metrics that are important to you. Are you tracking only accuracy? Are you tracking loss? Are you tracking performance, float operations, something like that? You could be tracking anything, but just make sure you're tracking your metrics. Another thing is make sure you take checkpoints. You save some of the checkpoints of your model, because of course, if your model training fails, you're gonna lose everything. So you might want to take a few checkpoints from time to time. What else is there that people also do? By default, most tools already track the resource usage, so you can kind of also be able to estimate how much you're gonna spend if you want to reproduce that experiment anyways. And finally, since you already have the checkpoints, you can use something like a model registry so that you can always go back. So now you have the three key pillars of reproducing. Of course, you also need to track your dependencies. So make sure you save your requirements at txt file, or most of the time, tools already do this for you by default. So make sure you can reproduce your experiment by tracking such environment files. So if you have these three things, you can, if you have code versioning, you can check out to that specific branch at our point in time. If you have the version of the data set, so you can easily download that from a remote storage, or even you can find it in your local storage. The model checkpoints actually don't really come in super handy right now if you're trying to reproduce. So you need just the first two. But the last part, which is the checkpointing, helps you kind of understand whether the model has equal kind of performance, if they're around the same place. And usually to do this, you use something like a random seed value so that you can kind of make sure that the results are consistent, even across different experiments. So I would say those three things are like super helpful. Data versioning, experiment tracking. Inside experiment tracking, you track your metrics, you track your checkpoints, you track your dependencies file, and then you check your that's it pretty much. You check only the model registry to make sure that you're saving all your models properly.
Well, that's a lot to keep in mind. I mean, just reportability and provisioning. And that's like, I mean, one of the questions that comes to mind when most of the time we do have conversation with other classmates and also people in industry. It's like there's so many tools in the LMOps space, right? And so which common tools you use on a daily basis, or how you like advise somebody approaching this field to what tools are those essential to like master or to get hands-on experience with?
Okay, so what do I advise people to get some experience with? If you are a
Based
data
on tools, I
scientist,
mean, based on the tools,
yeah,
so like
yeah,
even though
no, for sure. So if you're a data scientist right now, it would be a really good time for you to, if you don't know this already, master an experiment tracking tool or a metadata store tool. You have a lot of options, open source and closed source. So there's also TensorFlow Extended. They do this, but they already do this like automatically for you. So it's kind of a bit hard for you to have control over different things. You also have things like MLflow, Neptune, it's in biases, Comet, and so on and so forth. choose the one that works best for you, and stick with it. Learn how to use these tools. They're gonna accelerate you. It will give you back some mental space for you not to think about how to manage different CS. Usually, back in the day, people used to have Excel sheets to track different experiments. You don't need to do that today. Just find something in open source or closed source, and you master that first. If you're an ML engineer, you should also know some experiment tracking tool, but then start to focus on other tools, orchestration tools. You also need to know some model development tools or frameworks like PyTorch and so on and so forth. Even if you are an ML engineer, you're not excluded of knowing this. You kind of need to know this, and you also need to know some deployment tools that are going to help you deploy models into production, like there's Seldom and so on and so forth. There are so many tools right now in the space. We actually have a page with just tools. It's called MLOps tools, Neptune AI. It's a page just full of tools. So yeah, there's a lot of tools in the space. Find out what you need for your work, but if you're a data scientist, experiment tracking would be number one to keep in mind. Data engineers have a different set, because this is a team effort, so everyone has different tools to use, but I will just focus on data scientists and ML engineers or MLOps practitioners. You should know experiment tracking, you should know orchestration tools, you should know a tool for like deployment, and also cloud. It's also important to know how to work with the cloud.
Okay. Well, I think we would have to remember and also write down the resources after the podcast about the tools and everything. Also, with your article coming up, we'll make sure everyone turns on their alerts or whatever to anticipate to your article, social reproducibility and all that. Yeah, I know how we've spoken about being updated with like tools, and there's been a lot of innovation happening with people coming up with new ideas. I mean, the field of AI, there's always like new tools coming up. And so how do you keep updated with all these tools? Because I know you go for a lot of meetups. You also talk at meetups, especially in Poland and all that. But aside like meetups and all, I mean, you could also touch on that, but how do you also keep yourself updated with these things, with the developments of ML tools and also MLOps tools happening around the world?
I keep a very long Notion page where I just I think I have over 2,000 bookmark tweets and LinkedIn posts and Slack threads. The thing is, it's literally, I would say, virtually impossible for you to keep up with all the tools and still be productive at your work, because there's a tool every other day. And not only just speaking of tools, just the field itself, like what happened this past week, does not happen in a decade normally. Like we had a decade's development in 1 week, like from Monday to Friday, just banger after banger, like GPT-4, Alpaca, this new other model, and you're just like, okay, I need to find out, like, just don't try to know everything, just focus on, I do it because I think I'm the only crazy enough to kind of do this, to pull it off. But it doesn't mean that I catch up with everything. Some things I just have seen, so I know. And the events are good because I get to ask around and see how people are using different tools, different systems. I know people that don't have an orchestrator or pipeline orchestrator, but I know people that are using it at scale. They are deploying 2,000 models plus per week, sometimes multiple times a week. So it really just depends on your scale and what you're trying to do. I would say focus on tools that are gonna be at the intersection of value, meaning you need tools that fit your scale, fit your requirements, you need tools that have all the features you need, fit your skill and requirements, and can make your team productive. Because if you have a tool that is feature packed, we as developers have that mistake, or because most of the people in data science are coming from a development background, but it's like that tool has a lot of features, so that is so cool. But then, that tool can fit my scale of, like, let's say you're thinking about 10 years from now, you will have 100 million customers, but probably you won't have that from day one. But you're thinking about it that way. It's like that tool can scale to billions of people, but then it takes you 6 months to launch anything. So that is not a tool you want to use. You want to use a tool that makes your team work fast, or helps your team work fast, fits your scale, and has all the features you need. So that's what I call value. At the intersection of those three places, that's where you will find true value. It's not about build versus buy versus open source. It's about value. If you focus, I have to use open source, you are probably not considering maintenance and improvements. If you're talking about paid, you might be saying, I will have vendor lock-in. Make sure you build a robust pipeline that does not need one specific tool to work. You want a pipeline that's robust enough, like a Lego. You can just switch in any part if it's broken. If you go for an end-to-end tool, nothing against end-to-end tools. I actually have used some and I enjoy some of them. But it's like, well, if there is an outage, your pipeline is broken. Your production environment is going to just go down. So you don't want to put everything in with a single point of failure. This is why we switched from monolith software to microservices. So if you think about your pipeline as microservices instead of one monolith thing, you will build a robust pipeline that, if Google, AWS, whichever provider is gone, you can just be like, well, no problem. I will just switch this immediately. So those would be my 2 cents around this. It's just that there is so much to cover, and different levels. There are beginners, mediums, and advanced. That it's kind of there is no one size fits all. It just depends on each use case. Some people are using multiple machines with multiple GPUs. Those guys have different problems compared to the ones that only have a single machine with a single GPU or a couple GPUs. So there's a lot of use cases.
Yeah, it all depends on what your end goal is and what, as you said, value is. What matters is value, and that's the end goal, value. So let's talk more about value. We would want to know a little bit about, like, if you could walk us through a project that you worked on. It could either be a personal project or with maybe Neptune AI that you worked on, and how you went about it. Maybe just like a brief idea, because there could be someone that's working on something similar. So one project that you feel like the project of value, I would say.
I've worked on so many projects, but okay, let me see if I can pick up one. So I'll just take a couple of brief side projects. So recently I was working on using how to use Whisper to make sure that you can improve automatic speech recognition and just fine-tuning Whisper. So the first thing I did was fine-tune Whisper on a Portuguese data set, which is my mother tongue. Well, not really, but like adopted mother tongue. I fine-tuned Whisper on Portuguese and also fine-tuned it on Polish. And the way I went about it is the training took like 10 hours. And first of all, it was just the data pre-processing, understanding the data set, how is it structured, doing the pre-training evaluation. That's what we call exploratory data analysis. You want to understand the statistics of your data set. How many samples do you have? What is the mean distribution and all these different things? Those things will help you understand, for example, if your model is going to be biased towards a specific kind of accent or a specific kind of piece of information. So let's say if you only have text that's around one word, your model is going to be better at predicting that than any other word. So you want to make sure things are balanced. So that was like one thing. The second part was the model itself, building the loss function, and just kind of the model development part. And then I went into training. And for me, the most important part, because it was a 10-hour training, I wanted to be able to track it in real time so that I can just go to one place and see how my model is performing while it's training. So I could go to sleep and wake up and see the development. And that's where I use Neptune. Outside of working there, of course, I've used all other tools, but like with Neptune, it was very easy. At least for me, I know I'm guilty of saying this, but I could track the model development in real time, so I could see how the model was performing and stop training if needed. So that was like the most important part. And then after that, I pushed it to the Hugging Face model repo. So it's actually available for everyone to just go try. There, I have some spaces. They call it Hugging Face spaces. You can just go try out the model in your browser, and it's actually works really well. It predicts even the accentuation, punctuation on the text, even as you speak. So it was not trained explicitly to do that, but it does, and it predicts really well, really well. Another project was basically taking that and building an entire kind of interface around it for a course in my master's degree. So I built the data set. It had like 50,000 MongoDB records, and I built like a front end to it, and just how you can analyze this kind of large data sets on a web application using MongoDB as a database, like NoSQL. So there are multiple ways, and also putting it into production. So that was also pretty cool. Deploying an inference endpoint around this model was also quite nice.
Okay. Really interesting. It's just funny because I was also trying to play with the Whisper OpenAI API to transcribe audio for the podcast, and I'm happy at the experience. But I found it a little bit slow on my local drive, so maybe I think we'll talk more about that offline. But you did, in your article, right, the most popular article which talked about what LMOps is about. There's a level of LMOps you did mention 1, 2, and 3, which I found very interesting for those that are trying to implement LMOps into production in different organizations on different sites. So I'd like you to talk more about that. It's not like a standard approach of doing it, but I really found it insightful. So for big companies, smaller companies, and also, can you shine light more on that if you don't mind?
Yeah, for big companies, I think the size doesn't matter here in terms of like, well, you're a big company, but if it's your first ML project, it doesn't really help you as much. It's not like, oh, we are big, and unless you have a lot of money to throw at it. If you have a lot of money, you're big, you don't worry about those things. You can start off by building a team, an in-house team. You can have, there are different setups, but the most common I've seen in Europe is like a platform team and a data science team. So you need a platform team to help make sure that the data scientists have a easier workflow. Of course, some people, and the problem with teams is that in one team you might find people that have different choices. Some people might like one tool versus the others. So the platform team kind of helps ease that difference, so they can create like a unified, easy kind of a framework. What else? Make sure that you align the metrics that you're tracking around your model with the business goals. That would be something super useful. In terms of tooling, find out where you need super advanced tooling and where you don't. And like I said, build a composable ML pipeline, meaning some places you might have super specialized advanced tools. Some places you might be using an open source tool that just helps you do something easier and has low maintenance. The community is great. It's very active and they're doing a lot of development. That might help. And also try to, well, if you're a big company, you can also just build things in-house. It really depends. If you can do it, build it in-house, and it will be okay. But at the end of the day, I would always recommend to go with value, meaning if buying is better, do buy. If open source is better, go for it. In-house should be the last thing you should be thinking about. It feels like you're saving money, but if you really do the calculation of operation cost, you realize that you're probably spending way too much there. So yeah, if you're building a team, make sure that it's lean, mean, and has the right tooling.
Okay. Stay on the article and about your technical writing geekon, which is one of the things that you earlier mentioned of when we had a conversation offline. It was one of the things we got into Neptune AI. And so after reading your article, I mean, like, and I sent to a friend, and it was very insightful and really great piece. So how do you come about this masterpiece of, of articles? Because I mean, it's like a world of art, right? Like when somebody reads through it and goes like, you feel there's some depth that's been put into it. Like, it's like,
Absolutely.
Leonardo da Vinci's painting kind of like, but in the sense of, let me say, a piece of text, right, and information on a paper or on a blog, wherever you're reading from. But it was so insightful. So how do you go about? Is there a mental model you use to produce such beautiful piece of writing, or how do you approach this?
Oh wow, that is a really good question. My mentor used to say this to me. He said, Prince, whenever you are building something or writing something, focus on QHP. What is QHP? It's quality, honesty, purity. So I had this process of like, am I providing the best quality? Yes. Am I being honest about this? Am I bullshitting anyone here? No. Is it coming from a place of true service, or is it coming from a place of I want money? For me, it's more about what is the content that I will be remembered for, or the impact that I'll be remembered for. And content helps me do that. I can write something today that will still be useful for people in generations probably to come. So when I write, I take that approach of providing the most value in the most honest way. So for me, I really did a lot of research. The reference section is always filled up with all of the different things I've looked at, so that you can also kind of gain deeper insight if I couldn't manage to do it. But it also, in my writing, I avoid one thing, which is a lot of research papers in the beginning when I started 2017, they complicated things so that they could impress other researchers. I think that is an accurate way of putting it. Some people might disagree, but like honestly, when I used to read papers, it's like, well, are you trying to flex your ability to say complicated things? Well, this is so simple. I could see this in a Python function. So when I write from a place of I want you to see it as it is, and also feel like you're having a true conversation with me. For example, you will see I really take you on a journey. I want to take you on the journey of how I really went about learning this. Because there's a lot. There's a lot. You in the previous question, I only gave the high level part. We could have gone deeper and talk about things like data model validation, feature stores, triggers in your pipeline. But it's like I would need to set up the context for you to hear about that, right?
Yeah. Talking about taking us on a journey, so let's talk about how about someone that doesn't have a background in, let's say, MLOps. Maybe he has like a data science background, and there's also someone that is a software engineer but doesn't have any data science background. So that person, how do you start your journey as an MLOps engineer in that case? So,
I like that question.
yeah.
I like that question, but I would change only a tiny part, because there's this is a question I've been fighting a lot, especially in my podcast, I've mentioned this before. It's the following. Don't try to fit into the mold, like meaning a lot of people that are coming into the field are going into data science, but for example, some of them might have backgrounds in DevOps. Why you're gonna go like the most impact you will make is as a MLOps or ML engineer, not as a data scientist. But because when you look at the field, you look at, hey, this is the fancy thing, this is like the thing that everyone is doing, you are gonna miss out on your unique advantages. So focus on that. For me, it's weird because I know that talking is one of my unique advantages. So I want to be in a place where I can give talks, I can write articles, right? And make impact. And at the same time, I know that I have kind of expertise in terms of production environments. So I will take all of that, even in my own kind of personal projects like writing and kind of just thesis and so on and so forth. I focus on things that I have unique advantage of. Right now, if I go talk about robotics, it does not make sense. I don't know enough about robotics to build something at a truly competent level. So I would say if you have background in data engineering, why don't you focus on helping data scientists, or at least the most you could become is become a data scientist, or you could become a operations manager where you are kind of monitoring the data at the production level. You win very little by taking your existing talent, throwing it away, and saying, "Hey, I'm gonna become a data scientist just because it's the one that pays the most money or something like that." Focus on your unique advantages. You don't have any experience. If you are, for example, if you are a doctor, go be a researcher, go be a data scientist if you want to jump into the field, because you have domain expertise that a lot of people don't have. Now, if you are a doctor and you go become a platform engineer, your talents will be lost. Like it still does not make sense for me taking all of the existing talent and then just throwing it away. So use your unique advantages to build your career in data. Don't focus on a specific job necessarily. Find out, perhaps you will even create your own job. The platform people, they created their own job. The concept of platform teams is in MLOps right now. It's only coming more recently. But if you think about it, well, it makes sense. Data scientists need specialized tooling, and sometimes they were developing it, but not in a repeatable, scalable way that had like simple APIs. So their platform teams are software developers or DevOps people that have experience with all that, and they can just package it nicely and scale it across the team, right? And they can even help with the tooling, because in many teams right now, it's like, well, I use weights and biases. I use Neptune. I use MLflow. I use etc. So on and so forth. But perhaps the platform team can step in and evaluate all of those tools, security, things that data scientists are probably not worried about, but security and all these different things, whether you have the right certifications, etc. That is a job that software engineers have been doing for a long time. So if you have those skills, why throw them away? Right?
Exactly. So I mean, what you're saying is very true, because at the end of the day, it all boils down to researching and looking at where you can best apply your skills, where you can do the most. Because personally, I have a finance background, so every time people ask me, "Oh, why do you get into data science?" And a lot of people are going to data science because of like the money aspect. But for me, it was more like a personal thing. I researched into it, like I did like a test to see if I was interested in it. And I was like, yeah, actually, this is something that blends like my programming side and also my finance side as well. I can blend everything together. And I mean, I always have these arguments with he always talking about data engineering, how he wants to go into that side. I'm like, actually, there are a lot of jobs for it, but for me, I don't do away my finance side, and I know I would always work best there. So it's more, it boils down to having like a personal touch and understanding where you can apply your skills. And in me, I want a place where I could also give like business insights and advise businesses and all. So me personally going to MLOps, I'm like, that's not really my field though. So
Absolutely.
I agree with you.
Absolutely.
I agree with you. But then again, you mentioned DevOps, and there's this controversial question that everyone wants to know. What's the difference between DevOps and MLOps? Or are they the same thing? Is there a difference?
Oh, okay. That is the age-old question. So actually, there are DevOps. MLOps comes from DevOps. It's kind of it takes some inspiration from DevOps. So the way you can think about it is this way. I'll explain it because there's actually a simple graph in my article that kind of goes through this. So you have the dev and ops part. The dev part is where you're developing your model, your code, basically. You are creating, planning, verifying, and packaging your software. Then you go to the ops part where you are releasing it, configuring it, meaning the production environment, and monitoring. Now, with ML, you have new artifacts that you are taking care of, meaning you don't just have that part, but now you have a model. The model could be the weight file, could be the Python script. But if you think about the Python script, you're already taking care of that, right? In the DevOps part. Now you have the model artifact and you have the data part. So MLOps kind of addresses what DevOps was already doing, but extends it to the ML use case. So it's taking care of all those new artifacts that came out. But you're still doing most of the same things, like you're testing your pipeline, you're doing CI/CD, you are doing, there's a lot of the different things are there. You're also monitoring, but what you're monitoring is different now. In software, you're probably monitoring performance in terms of like how fast your script loads, etc. In ML, there's parallel to that, but probably it's not the first metric that you'll be focused on, depending on the use case. If you're doing batch prediction, meaning you don't need to make predictions in real time, you might be not focused on how much time your script takes, but whether it completed the job or not, right? If you're doing real time, you are measuring performance, but in terms of in terms of milliseconds, how fast things are running, what is your throughput, how many predictions per second, and things like that. There are myriad of ways you can go about it, but at the end of the day, I would say that MLOps takes from data engineering, takes from DevOps, and kind of addresses the entire ML space.
Okay. Well, that's really a great summary, the way you just put it, like where it takes from data engineering and DevOps. And still talking about these different career tracks, and we should also mention earlier in regards to also, choosing what is best and optimal for you based on your, I would say, your specific expertise. As we discussed previously in the past, like you don't have a training like in LMOps, and now you're in the masters in big data. So the question is how do you actually, let me say, develop a personal curriculum? Is something which you said last time you're interested and you're trying to work on. But how do you advise people actually to go about, let me say, putting themselves in a position where that actually, let me say, best fit to get certain, I would say, roles based on designing the personal curriculum?
That is a fantastic question. I think I should write an article about that because last time I was asked this on Twitter, I put up a thread and people were like, "Whoa, really? I wish I knew this before." I'm like, "Well, it came to me after a lot of pain." What was it? So I got started in ML. ML is just not. It's experimental in nature, so you really don't always know the outcome. But I realized, okay, Prince, There is AI, which encompasses a lot more than just ML. Then you have ML. Then in ML you have things like deep learning and classical ML. Cool. Okay. You have computer vision, you have reinforcement learning, you have NLP. Those are like the big three. Those are like the main ones. Of course, now we have time series and other things. How do I go about this? I think about it very, very, very simply. Think about the use case you want to solve first and narrow down the scope of what you want to try. In the beginning, I advise people try everything and find out what you like, but don't stay in that phase too long because you're gonna be overwhelmed. The pace of development across different use cases is astonishing. So what I did back then when I started was, okay, reinforcement learning, not for me, not right now. I'm gonna put that aside. I have computer vision, I have NLP, but my first use case is vision. I'm gonna focus on computer vision. Computer vision, let me start doing the classical algorithms until I get into deep learning and understand how deep learning works. So once I understood that, started, okay, let me see how these more advanced architectures work, dove really deep into computer vision. Then I decided, okay, let me jump and see how I can generalize this towards NLP. So that's where I kind of created a curriculum. On the first year, I was only focusing on computer vision. Then, after I finished that, I created a new curriculum for NLP. And the same thing I've been doing for years. This year, my main focus is natural language processing at scale. So I've created a list of books, articles that I'm going to read that are going to help me achieve that goal. And I also created kind of a comprehensive timeline on what I want to be able to do at a specific time of the year. So it's like, well, until date X, I want to be able to create a model from scratch. Okay, cool. How do I do that? Which books do I need to read? Which courses I need to take? So I focus on mostly use cases. That before it was just kind of areas. I had areas of interest, but now it's more of like use case. I want to be able to create a model that does X, and then I build a curriculum according to that. So if you're working on computer vision classification, image classification, create a curriculum around understanding very deeply what is computer vision, how it works, how the systems that you're using work. There are papers around this. So I also include papers. I include courses, papers, and books. Articles also, but articles kind of come as I go because there are new articles all the time. But I would say courses, papers, and books are the top three sources of information I get. And based on that, I create my own curriculum.
Okay. So I think the next thing that most of the time we always like to ask when we come at this stage of the podcast is like, your controversial thought. What do you think is highly underrated or overvalued in the field of ML as a whole, and why?
What is overvalued?
Yeah, overrated. It can be also undervalued if you just choose either of the spectrum.
I think right now there's a lot of hype in both ML and MLOps. And the thing is that hype is gonna die down soon when people start to realize that just having the best thing doesn't mean it's gonna be easy to go to production. It's the idea that if I have all of the best things, I will win. It's not always that. People should be focusing more on iterating. That is my contrarian idea because I get asked often like, how do I deploy my model safely in production? And I'm like, well, okay, what is your use case? I want to automate my model deployment. It's like, well, you've never done it before. Why do you want to automate something you've never done before? So they believe that just by using the best process right from the get-go, they're going to get the best results, while they should be looking at ML as it is experimental, and iterative.
Yeah, so I think at this point, just want to know, you've mentioned a lot of resources, and I think earlier on the show as well, you spoke about books, papers. So now, are there any books that you'd like to recommend or any advice that you'd like to give?
I would like to recommend Francis Chollet's book on deep learning with Python. That is a really good book. I remember that I actually printed the first version, so I didn't buy. And I told him on Twitter, I was like, I'm sorry, but I didn't have money back then to buy your book, so I printed it. But I promised him I would buy the second version, and I will. So it's a really good book if you want to get started with Keras and Python. And when I say this is for your beginner. So your beginner is gonna really enjoy this book to get started with. Another book, let me get here because another book would be Machine Learning Engineering with Python by Andrew.
Okay.
Yeah.
Okay.
So it's deep learning with PyTorch or Python?
No. Hey, machine learning. Okay, with Python. Sorry.
And there's machine
So
learning.
machine learning engineering with Python by Andrew McMahon. It's a good friend of mine. That book is very comprehensive in terms of going around the entire pipeline, and he has some really good projects end to end. Those are the books that I've read and I really enjoyed. Another book that I would recommend is Designing Machine Learning Systems. It's actually by Chip Huon, and it's like an iterative process for production-ready applications. So it's a really, really good book in terms of talking about production, understanding what monitoring is, what observability is, because some people conflate the two. So you can look at that book. That is for your more advanced user. So this one is for your MLOps practitioner that wants to improve their production platform, or is wanting to take it to the next level, like really scale it out. This is really good. It talks about even real-time processing and batch processing. So those would be the top books. In terms of courses, I would say Andrew Ng. He got so many people started in the industry, and even the MLOps course that I've just taken that has some of the links to my content. So he's always been able to deliver value consistently. All of the courses that he has, I've attended, meaning the machine learning from Stanford course and the MLOps specialization course. Those were really great courses. I really enjoyed them. Other courses, I think it would be something around Udacity. They also has some really good courses, but to shout out to any particular, since they have so many variations, I don't quite remember. So those are the places I look to learning. Also, yeah. One more book there would be Machine Learning Design Patterns. That's also a really good book. And in terms of papers, I would go, if you are just getting started, you don't know exactly a lot about the developments, start with the OJ papers, the AlexNet, ResNet, all those architectures, because nowadays, yes, we have super advanced models, but there are some use cases where a simple XGBoost model could actually outperform the most advanced models, or give you the performance you need. So start with the classical ones and gradually kind of get to know what's out there right now. But if you're an NLP, I feel sorry for you. There's nothing I can do. It's a fire hose. a lot of developments happening, and using the old one doesn't necessarily guarantee good use cases. Go
Yeah.
check out ChatGPT for
Yeah. Well, when should you also expect your book though? Because I was also hoping to hear machine learning by Prince or something. So
Oh wow, that is something
Absolutely.
I've been told for many years now. Like I think I would say my dad was the first reviewer of my articles. So he used to review my articles in terms of like grammar and things like that in the beginning. And he used to say, you should really write a book out of this. But
yeah.
I haven't done it yet because, like I said, quality, honesty, purity. I don't, I'm not yet at the point where I got into some material that I'm like, this is going to provide the most value for a lot of
Okay.
people, and it's coming from a pure place. So once I have that in place, I actually have some drafts, but like once I actually had achieved this state that I'm looking for, and this year is gonna be that year because right now I'm working on my thesis. There's a lot of things I've been learning, so I've just been collecting information so far.
Mhm.
I will definitely release something. It will be for free initially. I think I
Mhm.
won't charge anything on the first few. So just watch out on my Twitter. Just follow me on Twitter,
Yeah.
and you'll be able to see this. But you can also see my existing gallery of books on my Medium, meaning my articles are my books. You can also see some of my articles on the Neptune blog.
Yeah.
It has, well, combined, we have probably almost 3 million views. Alone, I have around more than 500,000 views. The Neptune blog has almost 2 million views per year or plus that. So I would say just look for my existing content, and one day I will combine it into a book. Right now,
One day.
I'm learning as much as I can so that I can provide the most value.
Yeah. One day. One day. We look forward to that day. So what's the next? What's the next thing for you? The big thing in terms of like your career, your learning, and
Whoa.
what's the next thing?
Yeah, and
Oh, wow.
it also goes in line with what we spoke about last time. Like there's some VCs reaching out to you also to advise them on LM up
Yes.
tools, and also working also in a startup environment like you. So I don't know what's next for you. That's in that sense, like we would like to know because
That
so many
that
things.
is a really good question.
Yeah.
That is a really good question. So, yeah, indeed, like I had a lot of VCs reach out and say, "Hey, Prince, I read your article. Could you explain me this in like in your terms, what it means, and can you give me like a small talk so I have like a presentation ready where I've given this over and over to a lot of VCs and just explaining them how the field is." And also showing them the amount of competition that exists, because a lot of people don't see the aggregate of all the tools, so you don't know that there exists a lot of competition, but there is. So I kind of go through this, and in terms of like what's next big thing for me, that's a really good question. The next big thing for me, I think, will be finishing my degree, like becoming finally a master, and now people will have to call me Master Prince. So yeah, finishing my master's, that would be like number one. And other than that, I'm just exploring building a lot of projects and just making really interesting content around how people could leverage a tool like Neptune to do all their various use case, just like the one I talked about in terms of like reproducibility. Those are things that I really enjoy because I know that there's someone that will benefit a lot from it. So for now, finishing my degree. After that, we will see. I have a lot of personal projects that I work on weekends, just like this one, and I have a lot of fun doing that.
Okay, I think we've come to the like to the end of the show almost like, and you for I mean for our audience to keep in touch with you for sure. We're going to share the links in the show notes for the article, the blog, Twitter, LinkedIn, and maybe your page on Neptune AI. Okay, but is there anything you feel we haven't touched or you would like to mention?
Okay, is there anything? I feel like right now there's a lot of noise in the space, and I just want to let people know that it's not the end of the world. Uh, Actually, more jobs are gonna be created than they're gonna disappear. All you need to do is prepare yourselves and also have fun in this journey. Life is all about not defending the status quo, but constantly upgrading ourselves. So if you want to jump on the bandwagon, it's not too late. You can always start, and don't worry about, everyone else that's doing amazing things. I think consistency is the amazing thing. Like doing the work day in and day out. And anyone can learn this at any age, because
Yeah.
it's not here to go away. Actually, it's here to stay. And we need to learn to adjust and how to use these technologies to our benefits. And this also goes to what I was saying earlier. Focus on using your unique advantages, your unique existing set of skills, and find a position or create a position within the MLOps pipeline or workflow that really you could make the most impact. Don't focus on the money. The money will come where quality exists.
Yeah, that's true. Better late than never, though. So yeah.
Absolutely.
Anyway, well, it's been a pleasure having you on the show. We've had such a great time. It's been very knowledgeable and very insightful. And I'm sure conversation would end here. Probably in future, probably have you again on the show. With you probably come back to talk about your book and all that.
For sure. I would
Yeah,
love that. I would love
yeah.
that.
So we are going to share, as Amma said, we will share your details with people that would like to reach out. And you also have a podcast, so we also share that link as well for people that also want to know more about the field, like MLOps, especially, and anything in the field of machine learning as well. So yeah, it's been such a wonderful time having you on the show. We've had a great time. I'm sure Amma too has had a wonderful time as well.
Also, I just want to do a shameless plug, but like this is gonna be a lot beneficial to a lot of people. If you want to understand or know more about MLOps in general, join the MLOps community. You will find me there. It's zero cost, and they do events around the world. So if you're around Europe, we might meet one of these here. So it's a very, very great community. A lot of the interesting guys, even some of the authors of the books that I mentioned here, are also there. So really just, join in. It's gonna be super cool, and we can, chat there.
Yeah, I think that's also a nice one you didn't mention because a guest on our show from Mastercard was also where I met him. I met him at the MLOps community here in London, and after watching your videos, did mention that to you. So nice shout out. Okay, thanks guys, and thanks for having us. I mean, thanks for coming on the show, Prince, and thanks William. So for now, bye.
Bye-bye.
Bye. Just stop there.